We've been slowly easing towards this topic, and if you've been taking the podcasts in order, you're now ready to think about statistical analysis. So the goal is not to make you into an expert statistician. These goals go to the point of getting you to think through what you're doing and what you want to know at the end of your study before you arrive at the door of the statistician. If you're paying by the hour, don't waste time faffing around. We're also going to talk a bit about the utility and importance of planning your analysis up front. The first critical information that you need to have nailed down is the primary question and the comparison groups that you want. If you're confident in your design choice, you can go even further. If you need advice on the design model, get it. You also need to have a sense of what data you're collecting. If you're able, sketch out the overview of what you anticipate the analysis will be. We'll have more on this later. Look how much information about analysis can be gleaned just from this specific research question. We've seen this question in earlier podcasts, but from this very detailed question, we have the primary outcome, the inclusion criteria, the number of comparison groups, and a sense of the types of data to be collected. This is the level of detail that your question should have, and this particular question is ready for the statistician. This critical detail is required before you look at sample size and power analysis, and is dictated by your primary research question. Primary outcome can be anything you want, as long as you can measure it. Things to consider include clinical importance, validation, accepted or wide use in the literature, test metrics available, and a sense of what is an important clinical effect size or difference. This is a much larger topic than we're giving it space for here, but in essence, questionnaires and patient-related instruments have characteristics that make them more or less useful for answering a given question. Metrics that are very useful for helping to calculate sample size or power include the MCID, the minimally clinically important difference, and standard deviation. Other factors such as reproducibility, responsiveness, or ceiling and basement effects will inform on how appropriate the questionnaire is for your specific situation and how to interpret the results you get. If you've got several possible choices, these factors may lead you towards a particular one. If you're not sure, get advice either from your statistician or from a mentor in clinical research. There are often scholarly papers available that get into this detail for a given questionnaire or instrument, so grab a copy for your statistician, since that may fill in important gaps for them. Inasmuch as the focus of this discussion is very much on clinical research, basic science research has similar issues to answer. Equipment and assays will still have test metrics, albeit different ones. Sometimes you just don't have access to test metrics or to enough data to calculate your power or necessary sample size. So what then? You may have to rely on some of these other approaches: pilot studies, best guesses, or established conventions. It's worth chatting with a mentor or other expert to see if there's a robust way to address sample size as opposed to arriving at best guess as your first step. So once you've nailed down as much detail about the question, the data instruments, and your design, you're ready to get at the statistician. So many of us have magical thinking when it comes to the powers of a statistician, but there are limits to their abilities. The major limitation is that the statistician cannot take a pile of biomass and turn it into gold. It does you, your statistician, and your intended audience a huge disservice if you drive a pile of data up to the door at the end of the project and ask your statistician to find something of statistical significance in it. Just don't do it. Consulting with a statistician during the planning phase of a project has several major advantages. The first is sorting out sample size and power for your primary and secondary endpoints. The more factors you want to analyze, the higher the N required, and they can help you estimate this. The second issue is planning out your statistical analysis ahead of time based on your hypotheses, data, and outcome measures. This is critical and avoids the bucket of biomass problem at the end. It's also good science. A detailed plan up front helps you resist the temptation to go on a magical mystery tour of data mining or p-hacking. It's not that it's carved in stone, but it will help you remember why you were doing the study in the first place. Furthermore, if you're applying for funding, you'll need a clear, appropriately detailed, and correct plan. You'll need to be explicit about how you arrived at your sample size, and also about how you will analyze your data after it's collected. Gone are the days where sticking something like data analysis will proceed according to the primary and secondary hypotheses, or appropriate statistical analysis will be conducted with the aid of a statistician. Funding agencies and reviewers will be much more likely to believe you can execute a quality and valid project if it looks like you have a clear plan of attack. The last advantage of early consultation is to plan for how to manage the data so that it's much easier to prep it for analysis later. So what do you actually need to give your statistician to help them help you? It's a little like when you refer a patient across to another doctor. There are certain must-haves and some would-be nice-to-haves. Remember how happy you'd be to get a call to assess a patient for undifferentiated leg pain or a tibula fracture. So the obvious must-have is the protocol, proposal, project summary outlining what questions you're asking and what you're intending to do. Some folks will appreciate some context in the literature, and certainly if you're using validated instruments, the metrics will be very useful. Finally, if you're working with someone new to you, or someone who's not already involved in the same research field, copies of the actual instruments can be helpful so that they can see how the data is being collected and what sort of data it is. So this is an example of how you can organize your thoughts about a statistical analysis once the planning phase is complete. Is this detailed? Absolutely. Does it demonstrate that there's a plan? Yes. Was there a statistician involved at some point? Yes, there was. Is it clear what I have to do at the end? Yes. I recommend this sort of approach, if not for placing in an application, then for your own benefit down the road. So having extolled the virtues of statisticians, the reality is that they are sometimes hard to find, you may not have a lot of cash to afford one, and for simple questions, you might not have to go through all of this. However, the worst situation is overestimating your abilities and doing the analysis wrong, or having missed a key step in the design, you're now sabotaged at the end. By all means fire ahead, but recognize your limitations and also ask for help from a research mentor if you're not sure whether a statistician is required. The other thing to remember is you can mix and match by looking after the descriptive stats and simple hypothesis testing yourself and contracting out the more complex analyses. This is often a cost-effective approach. In summary, the critical step is the research question. It should be clearly defined before this step. Statistical consultation in the planning phase of a study can be invaluable, and if you can access one, I recommend it. Finally, remember that statisticians are not magicians and cannot spin your biomass into gold. If you've done a lousy study or your plan was not well laid out in the beginning, they cannot fix that. In the next podcast, part 2 in the mini-series on statistics, we'll be looking at how to describe your data.